Good morning, everyone. Good afternoon, good evening. Here we are to watch 5 very interesting papers and their presentations of 5 cognitive studies in design. We have in this session one paper that received the Reviewer's Favorite Award. So I would like to congratulate the co-authors of paper number 5 for this badge. Congratulations, Fanika, and your co-authors too.
Thank you very much.
Yeah, I must say that all the papers are very interesting, so they got lucky with the reviewers. Because these are very hardworking papers, and of course, sometimes it's just a matter of being lucky with the reviewers. More demanding reviewers might be a little bit more tough with papers that are equally very interesting. So let's enjoy our session. I think we can start by with the presentations. Maria, the first one is by Yuri Borgianni.
And welcome to the presentation of the paper titled An Eye Tracking Study to Identify the Most Observed Features in a Physical Prototype of a Tiny House. The research in design field is attributing increasing attention to aspects such as cognition, perception, or experience. Design is concerned, among the others, with the built environment and the construction industry. In this domain, design is involved during the development of urban areas, landscapes, buildings, or the interiors. Those are consequently subjected to various design stages, like all the other products, including evaluation and prototyping. Prototyping and the representation can obviously take place in different forms. Among the others, we can mention pictures, which are common in the building industry when renderings are made, virtual spaces through virtual reality, or physical prototypes. The paper deals with a case study on the perception of an internal space of a tiny house which has been physically prototyped. I would like to underline that this case is really found also in the literature, because for a practical reason, the creation of physical prototypes in the building industry might result inconvenient in several cases. More precisely, the case studies regards the so-called tiny FOP mob. The tiny FOP mob is a physical prototype of a tiny house mounted on a trailer in order for it to be shown in different towns in the Vinschgau Valley in South Tyrol, Italy. The tiny FOP mob is built with local wood and with hemp. These features are supposed to make it an example of a sustainable product, and especially a sustainable product in the building industry. The scope of the tiny FOP mob project is to deliver information about sustainability in the building industry, and to create a real-world laboratory and a place for discussing topics such as sustainability in the mentioned Vinschgau Valley. During its journey in the Vinschgau Valley, many people have visited the tiny house. Out of them, 28 people agreed to visit the interior of the prototype equipped with eye-tracking glasses, which, of course, allow us to determine which points have been gazed instantaneously during the visit. In order to calculate the duration of gazed elements, The elements of the tiny folk mob were classified into 10 different areas of different. 3 of them are structural elements, walls, ceiling, floor. Others are named ordinary elements, which are features commonly found in buildings, while the ones indicated in blue in the slide are peculiar elements which are present in the scene for specific project purposes. The creation of videos has allowed us to split the videos, the recordings themselves, and therefore to calculate the duration of gazing on each of the 10 areas of interest. By analyzing the results, it emerges that the distribution of dwell times for each area of interest cannot be considered as distributed normally, which means high unpredictability of people's behavior, especially in this case where people were not tasked with anything specific during the visit. However, it emerged that dwell time, so the overall duration of gazing on peculiar elements, was significantly larger than times spent on ordinary elements. On their turn, the dwell times on ordinary elements were much and significantly larger than time spent on structural elements, despite those were the most characterizing of the tiny house. Indeed, through the texture of the wall and some elements of the ceiling and floor, the measure sustainability of the tiny house could be inferred. To sum up, structural and carefully designed element can be easily overshadowed by other characteristics. We ask ourselves if this applies also to other creative or novel designs. The results have confirmed the unevenness of people's behavior during the observation of a design, especially a large object that cannot be manipulated, such a building. The time needed to process a result is a clear obstacle to the wide-scale diffusion of the approach followed in the present paper. Analyzing videos took much longer than the duration of these videos themselves. The classification of areas of interest is original and potentially usable also in other contexts and studies. Insights can be gathered by analyzing individual recording more in details and maybe extrapolating typical behavior. Future work is intended to link eye-tracking results with questionnaires data which are not reported here. You find my contact details. Thank you very much for your attention on behalf of all the project partners and especially the authors of the present paper.
Okay, we're going to the next presentation, but before that, let me say, please drop your questions to each presentation in the chat, so we can then address them at the discussion. So presentation number 2 by Tijana Vuletic.
Design studies typically focus on exploring a particular aspect of a design process and can be difficult to document without interrupting that process. Post-study questionnaires or protocol analysis are sometimes used as a second or sometimes only data collection method. Post-study questionnaires may not record events that happen in the study accurately, and protocol analysis have weaknesses in capture of nonverbal processes and can include subjective inferences. Inclusion of verbal elements can detract from the main goal of the study, and it is often not the key focus. The study presented here explores the discrepancies between study participants' activities and their perceptions of those activities when they're reported post-study. The goal is to explore how reliable post-study evaluation is. This has not been explored in design contexts, but findings from other fields show that there have been discrepancies in what was performed during the studies and what was reported by the participants post-study. For example, when exploring media or social network use, significant discrepancies have been recorded, and in behavioral studies, it was even found that certain elicitation methods can induce them. Similar effects could be happening in design studies, and that is where motivation for this work is coming from. Study performed is a user-centered study performed as an extension of a larger study envisaging that, in the future, conceptual product design would be performed in 3D space, employing hand gestures as a sole or one of the modes of interaction. The objective of the larger study was to observe if the shape of the object being manipulated or its recognizability have an effect on the gestures used for the interaction, for example, object positioning, orientation, during conceptual design. These activities and objects were chosen as they were simple and easy to perceive and would not add more complexity to the study than needed. What is currently possible to achieve by available technology was not considered, and the study was performed by showing a number of videos visualizing a 3D object being translated up, zoomed in, or rotated clockwise. Participants saw the video for each activity twice. Then they were given a 3-second countdown and then performed the hand gestures they would perform to make the activity happen, pretending they were causing it. Measures were taken to avoid learning by randomizing the activities. Videos were limited to 3 seconds to record the participants' instinctive reaction, and the participants were not told what the goal of the study was. After they performed the activities, they were asked if the shape of the object influenced the gestures they made, and had the phone or a chair been a rectangular box or a chair-shaped box, would they interact with it the same way? The questions focus on object shape and recognizability. If the participant performed the same gestures for the same activity for different objects, it was assumed that the shape did not affect the gesture use. The recognizability in the context of this study is defined as a specific object having a specific recognizable function in the physical world. Sphere doesn't have a recognizable, usable physical world counterpart. A phone and a chair do have associated functions in reality. If recognizability of function was not included in the gesture interaction with the object, a larger proportion of performed gestures would be expected to be the same when used for the same activities for all 3 objects. 132 gestures were performed in the study. Overall, only 22 same gestures were performed for the same activities, regardless of the shape of the object. If we observe the effect of the shape on the object specifically, when asked if the shape of the object influenced the gestures they made, 38 participants stated that it did, 2 stated it did not, and 4 didn't know if it did. In the table highlighted in blue, we see that on average 74% of the 38 participants that stated that the shape of the object influenced the gestures they made did perform different gestures for different shapes. Shaded in yellow, it is visible that out of the 2 that stated they performed the same gesture regardless of the object shape, only 1 did so, and only to zoom out. 4 participants didn't know what they did, and about 50% of them, of their activities used the same gestures regardless of the shape. Looking at the recognizability of the object function, it was expected that if the recognizability was not influencing gesture interaction with the object, then the same gesture would be performed to interact with the sphere as it would with the phone and the chair. Blue shade shows that out of 21 participants that claimed they would interact with both objects in the same way, only 17% did. Yellow shade shows that out of 15 participants who claimed they would perform a different gesture for objects if they were not recognizable, 89% actually did perform different gestures, and 8 participants didn't know what they did, and around 25% of them performed the same gestures in all cases. The graph shown here illustrates that by relying on participant statements, for the participants that believed shape or recognizability of the object was influential, their statements and activities generally match up. Accepting the statements as valid, this would lead us to the conclusion that shape and recognizability of the object influence the gestures used to perform them. We then performed chi-square goodness of fit calculations to examine the likelihood of participants performing the gestures by chance for each of the 4 categories to further test this. For the shape-based calculation, the stated and observed analysis both show that the results are not likely to have happened by chance, as p is lower than 0.05. For the recognizability-based calculation, observed values have the same result. However, for the stated values, p is 0.317, and that would lead the researchers to the conclusion that the effects may have happened by chance. If the study was performed without the observation, and the results were based on verbal statements from the questionnaire only, the researchers would have concluded the repetitions may have happened by chance and that findings cannot be extrapolated from the data. If the study was based on observation only, the researchers would conclude that the repetitions did not happen by chance and that recognizability may be influencing the gestures. As both types of data were collected, it is now known that the results are conflicting, perhaps indicating that the question in the questionnaire was not clear enough, or alternatively showing that perceptions participants have of their own activities are not always reliable. While these findings do not provide definitive conclusions on participants' perception of their own activities, due to the small scale of the study, they do indicate that perhaps more focus should be put on objective measures rather than participants' perception of their own activity. We are planning to, in the future, apply similar analysis to other data sets that include data about uninterrupted product design activities and protocol analysis or post-study questionnaires, further exploring participants' activities.
Okay, so now presentation number 3 by Keisuke Shoji.
Hello everyone, I'm Keisuke Shoji from Kyushu University. Today I'd like to talk about the findings of grasping resonance from biosignal indicators. Here is the outline of my presentation. Let me start with introduction. The creative moment is observed in both individual and collaborative design process, and collaborative designers know that resonance includes something more than just a set of individual creative states. As you can see, there is a study from the perspective of subjectivity's experience. However, a difference between simultaneous individual creative states and a resonance creative state echoing the creative moment has still to be well understood. The difference has been qualitatively discussed in collaborative design studies, mainly from the perspective of outcome, and many studies using EEG have been conducted recently. However, EEG allows only limited movements, and it is difficult to interpret further than its measured activity. So the purpose of this study is to try to grasp resonance during co-creation with biosignal indicators. I will introduce research methods and an overview of this experiment. We conducted an experiment with pair concept generation which can involve resonance and compared the quantitative and qualitative data obtained to investigate resonance movement with biosignal indicators. The details on how to process these data will be presented later. The experiment was conducted with the examinees and in the experiment environment shown on this slide. They were already familiar with collaborative concept generation, and the tasks were conducted for about 20 minutes. Immediately after pair concept generation, each of the examinees individually reviewed their pair work with recorded materials. The examinee were asked to work in a pair on a concept generation task based on a combination of two different nouns. They also chose a combination of two polymorphs known for this experiment, rather and drawing for more interpretation and to have a similar condition among examinees. And prior to studying experiment, examinees were told that there would be no evaluation of their concept to avoid inhibition they might feel when generating their concept. For example, you can see on figure 2 the concept a canvas set for drawing crowds proposed. Referring to previous studies, we selected biosignal indicators that are considered to reflect emotional and cognitive aspects. The examiner interviewed each examinee to add examinee's thinking process to record sheet as shown in figure 3, corresponding to the transition of creative states, reviewing the video recorded during the experiment at the same time to tag each of states in the experiment timeline. The examinee were also asked to specify the timing of when they felt resonance. I will introduce evaluation methods. For the subjective evaluations, we finalize the creative state into creative or non-creative state for each examinee based on the transition of the creative state, thinking process, and the recorded video. Based on the individual subjective evaluation of the creative state above, the creative state in the pair was categorized in the 4 categories as the squared area on this slide shows. I will skip the detail. However, for the objective evaluations, we performed a correlation analysis, calculated the Levenstein test, and evaluated the amount of activity with a preprocessing shown on this slide. Now, I'd like to move on to the result and discussion. I won't go in details. Both correlation between biosignal indicators and between examinee in a pair has no clear tendency. Thus, correlation analysis cannot sufficiently cover the chronological misalignment of waveforms. As Let's Squared earlier shows, there is a significant difference in one-way ANOVA in vertical eye movement. When they felt resonance, the examinee's reflection also suggested that positive empathy was allowed toward generated concept and synergistic idea development was observed. Therefore, resonance can be understood to be a divergent phenomenon, and Levenstein distance of VEOZ may grasp this divergent aspect of resonance. There is a significant difference in one-way ANOVA in all FEMG, and there is a significant difference between HH and R for collegial superciliary and oviculus ocular muscles in the pair test for multiple compression using the Benferroni method. As Figure 3a and b shows, the activity of collegial superciliary and oviculus ocular muscles increases when examinee feels resonance, and from this result and examinee's reflections, synergistic and responsive idea generations were observed after the laws of positive sympathy. Therefore, these collegial superciliary and oviculus ocular muscle could grasp positive and active aspects of resonance. There is a significant difference in one-way ANOVA for VOG and Mentalis. Previous studies suggested that the depth of cognitive processing of the language is related to activity of Mentalis. Blinking is also understood to become more frequent during focused thinking, and from the examinee's reflections during resonance, synergistic and responsive idea generation were observed after the laws of positive sympathy. Therefore, it could be suggested that resonance can be grasped with these biosignal indicators reflecting positive and active cognitive aspects of resonance, although further experiments and analysis will be needed. The Levenstein disk has a tendency to return a large value for active waveforms in general. The result of Levenstein disk could be affected by the basic trend of the result of activity assessment per creative state. Therefore, the reason why a clear trend in the Levenstein disk analysis of the resonance was not obtained in this study is that they may have cancelled each other, as there is an increasing trend of Levenstein disk due to the active waveform and also decreasing trend of Levenstein disk due to the formation of intersubjectivity. I'd like to finish by summarizing the main findings of this study. First, the significant difference between resonance and a mere creative states were found in activity assessment with collegial superciliary and oviculus ocular muscles. Although no significant difference was found, resonance could also be captured with VEOG, which could reflect the active thinking and divergent aspects of resonance, with a loss of positive sympathy as blink intervals. The aim of this study was to gain an overview of a basic direction that can be used to grasp creative state and resonance with biosignal indicators. There are some limitations as shown at the upper part of this slide. The aim of our future work will be to improve and better focus by excluding the side effect noted in this study. Thank you for your attention.
Okay, so I remind you again to please drop your questions in the chat for discussion. And now, presentation number 4 by Enrique Duffy.
Inspirational stimuli improve idea fluency during ideation, a replication and extension study with eye tracking. My name is Enrique Duffy, and I've had the pleasure to collaborate with Philip Abelsson, Pasi Alto, Kosa Goucher-Lambert, Martin Steinert from NTNU, and UC Berkeley. We replicated the experimental design and stimuli of a design ideation study and extended it by changing and adding new sources of data collection. The original experiment tasked participants to generate ideas for design problems, aided by inspirational word stimuli that was either near or far from the solution space, while undergoing an fMRI scan. We didn't have an fMRI, so we used an eye tracker and a think out loud protocol because we wanted to investigate visual allocation and have a record of the generated ideas. Moreover, we obtain a more realistic context by moving to an office with a desk, and it becomes interesting to investigate if the results overall hold. The task, problems, and words used in this experiment are exactly the same as in the original study. To explain it a bit further, We had participants develop as many ideas as possible for 12 different design problems and instructed them to briefly explain their ideas in a Think Out Loud protocol. 5 words were presented along with each problem in 2 blocks of 1 minute. The first block was called Word Set 1, and it displayed the 3 first words. The second block, Set 2, displayed all 5. We had a control condition that used words from the problem statement, while words near and far from the problem space was used as inspirational stimuli in a near condition and a far condition. Participants also completed a questionnaire that rated the usefulness and relevancy of the words presented, as well as the novelty and quality of ideas on a 1 to 5 point scale. After we had 24 participants. None of them were native English speakers. All of them were graduate level students, and they had a similar educational background as the original participants. To summarize, the following data modalities were collected during the experiment: eye tracking data, audio recordings, the number and timing of generated ideas, and a questionnaire. The scope of this article is to analyze the number of ideas and subjective ratings from the questionnaire. Results. For the subjective ratings, there was a highly significant difference between conditions for relevancy and usefulness. There was no significant difference for novelty, but quality had a p-value of 0.051, which is noteworthy. So to dig a bit deeper, for relevancy, there was a significant difference between control and near and between far and near, with near being more relevant than both control and far. For usefulness, there was a significant difference between control and far and control and near. So the inspirational stimuli conditions were rated as more useful than control. Moreover, the difference between far and near reached a significant level of 0.05 for usefulness, which we find interesting and interpret as a strengthening indication of that near was also more useful than far. So these results exhibit a similar trend to the original study, with one exception: relevancy. Participants in this study rated control to be less relevant than both near and far, whereas the original participants thought control was more relevant than both near and far. So we noted during the experiment and in post-experimental feedback that participants were quite unsure of what relevancy to give to the control stimuli, and this may explain the difference. Participants were also not native English speakers, which may interpret their interpretation of both the question and the word relevance. This, in future studies, could be potentially clarified to assess whether it was the relevancy of the words based on their relevancy for solving the problem, or if them being related to the problem. For usefulness, the near and far inspirational stimuli was rated as more useful than control, and this corroborates results from the original study. So for idea generation results, the number of ideas produced in word set 1 was significantly higher than those produced in word set 2 across conditions. Now, when we look at the number of ideas generated for each condition plotted over time, it exhibits a similar shape as in the original study, but it has an approximate 10 seconds temporal delay. We think that this might have been caused by participants both being not native English speakers, but also the Think Out Loud protocol, or maybe some combination of other factors. So based on the figure, near stimuli appears to generate more ideas than far, again generating more ideas and control for both word sets. But this was only a significant difference in word set 2. Here, there was a significant difference between control and near and between far and near. This indicates that inspirational stimuli help participants retain a higher idea output throughout and especially towards the end of the ideation session, which concurs with the original study. Both studies' mean values of ideas output were indeed near greater than far, that again were greater than control. So in conclusion, the results presented here corroborate the original study's results, which is that inspirational stimuli influence idea output and questionnaire ratings. Participants produced more ideas over time when aided by inspirational stimuli and rated inspirational stimuli as more relevant and more useful than control. We're currently working on analyzing eye tracking data and audio recordings. And everything's available for reproducibility purposes should you wish to run the experiment or have a go at the data. My name is Henrike Dubvik. Thank you for listening.
Okay, and now we go to the last presentation by Fanika Lukasiewicz.
Hello, everyone. I'm Fanika, and I will present the paper that was jointly delivered with colleagues from the University of Zagreb and Politecnico di Milano. In the study, we measured and compared EEG brain power of mechanical engineers in 3D CAD modeling from 2D and 3D representations. Creation of virtual models using computer-aided design tools is one of the basic engineering activities, and as a higher level cognitive activity, CAD modeling has its perceptual and production component, which means that to perform it, one must perceive and act upon a stimulus, a mental or a visual representation of design. In this work, we concentrated on CAD modeling from technical drawings as 2D visual representations that are mediated via monitor screen. 3D CAD modeling from a technical drawing requires one to interpret the presented design information, visualize the three-dimensional representation in mind, break the mental representation into features, and finally, create a 3D CAD model using Boolean primitives. Previous studies of CAD activities often measured engineers' external performance or observed their behavior using methods such as protocol analysis and analysis of log files that are available from CAD tools. However, these studies did not consider cognition that underlies CAD activities, possibly because they lack the objective methods for its monitoring and for its measurement, which we recognize as a research gap. Method that might help us to bridge or at least to narrow the gap is electroencephalography, EEG, one of the neuroimaging methods that in recent years have been introduced into the research on design cognition. EEG is non-invasive, it has a high temporal resolution, and allows for continuous monitoring and recording of brain activation in natural working environments. Thus, it seems to be particularly suitable for investigating cognition that underlies CAD activities. We have conducted the preliminary experiment in which we wanted to see if EEG will reveal differences in brain activation and in inferred cognitive load that was imposed on engineers while they were CAD modeling from two types of projections, from orthographic and isometric projection. We hypothesized that brain activation and cognitive load will be higher in the condition with the orthographic projection, since it was assumed that the additional cognitive resources are needed to mentally manipulate spatial information that is presented in 2D views of the orthographic projection and to perceive the part in 3D. In the experiment, the signals were recorded with the 14-channel Emotive Epoch Plus device. For the representation of the projections and CAD modeling, we used two monitor screens. The left monitor mediated the visual representations, instructions, and baselines, while on the right monitor, the SolidWorks window was opened, in which participants created CAD models. In total, 20 male mechanical engineers, young professionals, participated in the experiment. Half of them first created 3D CAD model from the orthographic projection and continued to the isometric projection, while the order was reversed for the other half of the participants. In the pre-processing step, data gathered from 3 participants of the initial sample were discarded, which means that the presented results were based on the analysis of EEG data from 17 participants. In particular, we analyzed the total signal, alpha band, and theta band task-related power, since the cognitive load in the previous studies has been persistently correlated with changes in these frequency bands. Firstly, we compared task-related power between the projections across all the 14 channels and for the entire duration of the tasks. In all the bands, 3D CAD modeling from the orthographic projection showed higher cognitive activation than it was the case with the isometric projection, by which we confirmed the first part of the hypothesis. Secondly, we compared the task-related power recorded by the individual channels, where larger dots imply higher effect size of differences. In this work, we did not try to correlate task-related power from the channels with the functions of the cortical areas within which the channels or electrodes are positioned, since we used the EEG device with a relatively low number of electrodes, with 14 electrodes, which would make such an analysis potentially unreliable. Because of that, low spatial resolution of the used EEG device should be noted as one of the study limitations. Furthermore, we identified several effects that were previously related to visual processing of spatial information. For example, significant differences between the activation of the hemispheres, where the right hemisphere was more activated than the left one during both tasks for total signal power and for theta band power. Finally, we found that the mean value of the cognitive load index was higher than CAD modeling from orthographic projection, by which we confirmed the second part of the hypothesis, but only partially, since the difference was not statistically significant. The lack of the statistical significance may be related to the sample size, so the sample size should also be added to the study limitations. Besides, we calculated the cognitive load index as the ratio of the mean theta power from the channels positioned in the frontal lobe and mean alpha power from the channels positioned in the parietal lobe. This calculation was adopted from the previous related studies, but it's not the only one. So in further work, we will calculate and compare results when we are using different metrics for calculating cognitive load. To conclude, the presented study showed that we can measure, describe, and compare brain activation in CAD modeling tasks using EEG. The study results imply that relative differences in brain activation and in cognitive load do exist, and they can be detected when using different types of visual representations for the same types of CAD activities. However, the interpretation of the brain activation and the meaning of the detected differences are yet to be defined. In our further studies, we will try to provide additional insights and potential explanations by complementing the EEG data with CAD log files, by relating the brain activation with the final CAD models, and by conducting the temporal analysis. Thank you for listening. If you have any questions, I will be happy to answer them during the discussion part.
Okay, so we have watched the 5 presentations and we're now going to start the discussion. I see that we have many questions in the chat by now, but first I would like to ask the presenters if they have direct questions for a particular presentation. They will have questions they would like to ask. No?
I have one small question for Fanika, and I was wondering about the duration of the CAD modeling, how long time it took for the participants to kind of do the task.
Thank you very much for the question. So obviously it is different. It differed among the participants because they were not limited in time. So the task pretty much ended when they were done with it. And I would say that approximately it was between 30 and 40 minutes.
Okay, and the results, are they kind of averaged across that entire time series?
Sorry?
The results that you presented, they're kind of taking into account the entire time series and the 30 or 40 minutes.
Yes, that's right. So in these preliminary results, we show everything that happens during the entire duration of the tasks. As I said, kind of the first steps is now to segment the entire task into smaller epochs, and also to relate them to CAD activities, but we didn't have time to do it for this one.
Okay, cool. Thank you.
Kind of addition to that question, did you compare the time it took them to do 2D and 3D ones? Was there a difference between them, or was it comparable?
Yes, there was a difference, and it is actually statistically significant difference. So it took them longer when they did it, when they CAD model from the orthographic projection. And also we did a preliminary analysis of the first segment, so the segment when they are really just looking at the projections, and then they are CAD modeling. So it was interesting to see that for the first part, there is statistically significant difference. For the second part, so really when they are creating a geometry, there is a difference, but not statistically significant one.
Okay, thanks.
Welcome.
Fanica, more or less something that you find also in my question in the chat. So as far as I understand, each student worked with two different models, one an orthographic projection and one the isometric axonomic projection, correct?
Correct.
Did you have you had the chance to compare the complexity of the two tasks? So I guess that if given the same condition and two different models, if they take the same time to reproduce a 3D CAD, maybe they are comparable. Did you study and did you focus also on this aspect so that you can say that differences will be mostly due to the representation and not due to the different parts?
Thank you very much for the question. Yes, so in the study, we tried to concentrate really on the visual aspect of the task, not on the complexity. So we tried to keep both tasks at the same complexity level. So how did we define it, or at least try to define it, is based on the features. So when we were choosing or building these models, the idea is that you can build them from the same type and same amount of the features.
And did you notice variations in terms of the number of features used? Because of course you can consider that, don't know that for this part you have to use a minimum for features, but maybe people can do it also with 6 or 8 if they follow a process that it is not the most straightforward. Did you notice differences when they were given the isometric projection and when they were given the orthographic projection?
Well, unfortunately, we didn't have time to really dig deeper into the actions and the number of features that actually took them to create the models. But that would be interesting, to compare brain activation with their behavior while they were CAD modeling. So maybe what was their strategy? What was the order? How many times did they get back to the projection? And also to compare brain activity with the end results. So how do these CAD models actually look like? So can we maybe make a difference between those who actually provided good models and with those who didn't do it? So that is a step that we still have to do. But I think that would be really interesting to look into.
Did you get any feedback from the participants in terms of what did they prefer doing?
Well, yes, it differed for some of them. I mean, some of them told me that they are more used to the orthographic projection. I mean, this was more casual talk. I didn't get it from the questionnaires. Maybe it would be good to do it also in the next round. I mean, especially if you relate it to the cognitive load, it would definitely make sense also to use some kind of the NASA telex or something like that to see what is their subjective view of the cognitive load, or maybe of how much the task was difficult for them. But I think that from their subjective and casual responses, it was maybe it was easier from the orthographic in some point because we are used to it. On the other hand, for the isometric, they would sometimes said, okay, I didn't get this, this number correctly from the first time, and then I had to redo everything. So I would say that from the first input that they give me, it was kind of individual.
Yeah, because when I was looking at it, I was thinking orthographic, you can see dimensions better but then in the 3D one, you do actually see where they are. So there's a kind of a plus and a minus for both.
Exactly. Yes.
Cool. Thanks.
Were they allowed to interact with you or with the experimenters in case something was unclear in the drawing?
No, I mean, I told them if there is really some huge problem, kind of tell me, but the idea was that they don't speak to me at all. So they didn't. None of them asked me any of these questions, but I think that everything was pretty clear from really how the drawings look like. There is also something that we should take into account, because when you are making really technical drawings, of course, that each of us can do it in a different way, maybe. Maybe we will present some of the numbers on the front view, some of the numbers on the top view. But from what I got from the participants, they didn't have too much confusions on that part.
Okay, so shall we move now to answering the questions in the chat? Yeah. So we can start with the first question from John Giro to Yuri Borgianni. Have you compared your results with other eye tracking studies of architectural spaces? What are the differences that are the consequence of the space being small?
Okay, thank you for your question. So in the background of the paper, we described some experiences of using eye tracking by users, visitors, by observers somehow from the field of architecture and civil engineering. I must say that there are not so many cases in which the results are comparable, unless, of course, our literature review is non-comprehensive. We could have missed something. The only thing in common is that there is a study which highlights that the disturbing element capture much time of people viewing experience. So this is somehow one element which is totally supported also by our study. So it's quite hard for a designer. I don't know if this applies also to other kind of products, to other kind of designs, to make the observer focus on what the designer would like the participant to focus on. But it seems the disturbing element play actually a large role. So in terms of consequences and the differences of the space being small, we haven't come to that point, and I cannot really say any conclusions or provide any implications in this respect.
So if people in watching the session would like to share the screen and join the discussion, please do so. Okay.
Sonia, should I go ahead
with the questions? Yes, please.
Would you want to repeat or just go forward what is written in the chat?
Well, yeah, I can read the question. So could it be that the house typology is influencing the results?
Yes, it can. That the house typology can influence the results. In any case, people everybody had seen the tiny house from the outside before entering. This is quite natural. So they knew that they were inside the tiny house, which is on a trailer. Then regarding other features and characteristics, some of them could be a little bit aware of the main characteristics of the people. Someone wasn't. So this was in a separate study, putting into the relation their previous knowledge of the project and their characteristics, but doesn't belong to this paper. In any case, the impact of previous knowledge of the tiny house and the project around it didn't play a specific role. So surely some factor would be affected, but not the one we directly investigated.
Okay. Okay, next question. We have a question from Tijana to Keisuke. How could knowing when resonance take place improve the creative design process? And what's the practical implication of the study you foresee in the future?
Okay, thank you for your questions. And as a practical implication, I think there is a biofeedback to match the better creative process. And also, as a theoretical implication, this is a first stage to understand the, mechanism of resonance. So this is my answer. Is it enough?
Yeah. Okay, next question. Another question from John Giro. Not being native English speakers is a confounding variable. Did you check the participants' level of confidence in English as a covariate? So this is for Enrique.
Yes, thank you very much. No, we did not check for participants' confidence in English. In retrospect, that would be a very good thing to have done, and that I will keep in mind for future studies. But no, we didn't.
Okay, next question from Yuri Borgianni to Enrique. Which eye tracking data will you be actually working on? How were these captured?
I'm not completely sure I understand the question. Do you mean the metrics that we derive from the eye tracker or the eye tracker itself, or both?
Yeah, both. So the eye tracker itself, which category of eye tracker? So if they wear glasses, remote eye tracking?
There were glasses, binocular glasses, meaning 2 cameras and 1 infrared, and 1 world view camera, of course, so 3 cameras in total.
Yeah.
And then for the eye tracking metrics, we're good.
Where the words and stimuli located when participants were interacting with these sources of inspiration?
Could you repeat that, please?
Were the words and the sources of inspiration on a screen or around?
Yes, they were presented on a screen, a regular desktop. It was...
Okay. Wouldn't it be better to use the remote eye tracker maybe in these circumstances? Or
it might have been.
Of convenience?
It might have been in terms of participant comfort and kind of the how natural it feels. But then it would have been better to have like a web camera or an infrared eye tracker situated on the computer. We had the other eye trackers, so that was basically why we chose the glasses, and also for the possibility of doing future experiments is kind of the reason that we have this particular type of eye tracker and having it integrated in, for example, more naturalistic environment as yours is.
And which metric do you intend to elaborate, if I might ask?
I can say a bit. We're going to be presenting some preliminary eye tracking results at DCC in about a month, a bit over a month. But to begin with, I'm going to be looking at the kind of the fixation distribution, so how much they focus on different areas of interests. Again, kind of similar to what you're doing. And then we're also going to be looking at saccades and so on. But then we haven't fully decided every detail of the analysis as far as we are right now.
Okay.
Thank you.
So next question. So also for Enrique, participants describe what they are thinking or how they thought about it.
Thank you. So we instructed participants to explain their idea. So not necessarily what they are thinking about the whole setup and about the experiment, but what the resulting idea
So
was.
it's more kind of retrospective feedback.
Oh, well, I guess so.
Yeah.
I'm not sure how to properly define it, because we told them to, when they had an idea, please explain what the idea was and, indicate that you had the idea. So for some participants, they would kind of press and then explain the idea. And then other participants would kind of explain their whole idea and then remember to press and indicate that they have had the idea. So that was different between participants in terms of the timing of when they indicated that they had an idea and when they explained what the idea was.
Okay.
I hope that was clear.
Yeah. Okay, so there's another question from Tijana to you. In addition to Yuri's question, are the works and other stimuli in the same space that can be tracked jointly?
I misspelled that, words, not works.
Could you just explain it again?
So just wondering about the setup. So the words were on one screen. Was there anything else that they were looking at? So what was it exactly that we were tracking when you were tracking their eyes? Was there anything else that would draw their attention other than the words?
Not really. There was a very plain desktop setup. We did have a microphone in front of them, so we haven't yet analyzed whether they actually paid attention to the microphone. But nothing kind of that stuck out. It was really only like a pure screen-based kind of thing. There was a window next to it, and I know that participants did spend some time looking outside the screen, but it doesn't appear to be on anything specific. I hope that was sufficient to answer the question.
Yeah. Just wondering.
Great.
Okay, now a question from Yuri to Fanika. As far as I understand, all the students had to work with two different drawings, 2D and 3D. Did you manage to investigate if their complexity was comparable and differences were just due to representation methods?
Well, thank you, but I think that we kind of answered this one. Correct me if I'm wrong.
Yeah, I think so too. Yeah.
Okay.
I don't know. Yuri, what do you think?
Yeah, maybe Yuri should decide.
Yeah.
No, you have already answered.
Okay.
We have already stressed you on this aspect.
So, and the next question from Tijana, and which order did? Well, I don't really.
Yeah, you answered that one too.
Yeah. This one is also okay. So this last question for Fanika. How do you think this line of studies contributes to improve CAD systems?
Yes, okay, so that one is the tough one, thank you. So for the CAD systems, I mean, what we are at least started to do is to investigate, I would even say, visual spatial thinking of designers, which is kind of a broad topic. Now, we decided to go with CAD system because it is one of the systems that designers regularly use nowadays. And we noticed that in the previous studies, also using, let's say, protocol analysis, what was often observed was sketching and not really CAD modeling. Now, in this first study, we measured and we get the brain activation of engineers. And we are trying now to figure out what we can really infer from it. So I would say at the current status of the design error recognition, we can kind of report data. I think that this also relates to eye tracking data, but it's kind of hard to make a direct conclusion on how to change something or really to make a decision on how to improve some as a CAD system. I think that an easy goal would be to do something similar that they do with human-computer interactions. So basically, when they look at the different sites, how people react to icons, where to position them. For this type of the studies, I think that EEG and eye tracking, let's say, should be combined really that we are maybe a bit more sure what designers are really looking at and maybe try to relate with cognitive processes. So I think that besides of the description, that would be really the first point, maybe how CAD system could or should be rearranged. And then in the next step, maybe we could think a little bit more broadly about, I don't know, redefinition of CAD system or something like that. This is also a really beginning maybe of something that started with brain-computer interface, but I wouldn't be so brave to say that we can directly with this and at this moment talk about brain-computer interface, but I guess with at least descriptions of brain activity and designers' behavior at this moment, we can kind of make these first steps toward that goal.
I mean, not to say that I know what you're going to do with your work, but it would be interesting to see if, because I've supervised a few students that were looking at how they can improve technical drawings, it would be interesting to get from your paper, what can people actually read easily? Should we change the way we document things? It's not quite CAD system, but what is the best way to actually have a drawing people can read? That's one of the things that could maybe come from it.
Yeah. Tijana, do you think your results can also contribute to this kind of results of your paper can also contribute to, I would say, maybe not CAD systems, but indirectly, I would say.
Yeah, maybe indirectly in the sense that it's looking at similar things in the sense of what people perceive and what they understand. Mine were much simpler because I was going for kind of first reaction and didn't give them time to think. But it is kind of aiming at the same idea of, are we doing this the right way? Is there a better way to deal with 3D shapes?
Mm-hmm. Okay, any more questions from the audience? Whoever would like to share the screen with us and talk to us, please do so. Step in. Or co-authors that might be present. Any further question? We still have some minutes left. I would kind of launch a question for all the presenters, because this is a session on cognitive studies in design. What are the main results of each one of the 5 studies that contribute or bring new knowledge to design cognition?
If we are going in order, in order of presentation, I will go first.
Yes.
So I think that maybe our study was not directly related with the design cognition, also because we focused on design recipients rather than designers themselves.
Mm-hmm.
But, however, I would say that based on your question, I would surely answer we have to pay very much attention when we design, because what we do might not be captured by our observers, by who should evaluate the design the way we would like. Mm-hmm. So the alignment of cognition between designers and other stakeholders, I think, is a critical issue.
Yeah, and it comes out from your paper for sure. So number 2, Tijana.
So I think mine actually probably asks more questions than it gives answers, but I had, where it came from is I struggled when I was doing a larger study that's linked to it. I wasn't sure I was actually measuring what I thought I was measuring. And I think there's a bit of kind of methodological issues with design cognition when it gets applied, because it's quite difficult to measure across different media and across different representations. So I think there's probably more work in the field in finding maybe a bit more standardized way of doing this, and maybe using new technologies that we now have, where we can be sure that we are actually measuring what we're aiming to measure instead of getting conclusions that are maybe not right.
Mm-hmm. Okay, so number 3, Keisuke.
So I'm sorry I couldn't the question. Phrase it.
Shall I rephrase it?
Yes.
So what are the main results from your study, or they might be direct or not, results to cognition in design?
Oh. So in my study, the reason, yeah. So resonance is the cognitive side and the emotional side, and it is, how to say, difficult to interpret the.
There's some interference. I don't really hear you that well. Would you like to try again?
Try again? Okay. Oh, yes. In my studies, resonance has the cognitive side and the emotional side, and it is difficult to interpret its measured activity as cognitive activity. It is my main result, I think.
Mm-hmm. Okay, so Enrique now, right?
Yes. So the original study that we replicated already kind of found that inspirational stimuli does work in the sense that it helps you create more ideas than if you aren't inspired.
Yeah.
And the study that we did kind of shows that this holds also when you're not an American student, when you transfer culture and you transfer context, and also you pull people out of a very small confined space that is an fMRI and put them into something that's still quite confined as it is a very boring desktop setup. But then again, it's maybe a bit more realistic compared to what practitioners would do today. So in a sense, showing that it does hold in more realistic situations as well.
Okay, and Fanika, would you like to answer?
Yes, thank you. So I would say that from what we can get from the study as it is right now, so from these preliminary results, is that there obviously are some differences in brain activation when we use these different visual representations. On the other hand, I share the feelings with Tijana when she says that the study opens more questions than it actually answers them. It, I guess, makes sense since it's a preliminary study, because we still have to now understand why these differences exist and what we can actually do with them. But it seems that it's not the same if we represent the design with 2D drawings, with 3D drawings, with CAD models. It obviously affects designers, so we should take a deeper look into why this happens and how we can maybe work on creating CAD systems or other human-computer interaction tools to really make the entire process more efficient.
Okay, thank you. Okay, we still have some minutes left. I would, if there are no more questions, no, I would ask something else, not something else, something specific. Where do you think this field is heading to? Some of the studies that we watched today, the presentations, they are based on studies using neuroscience methods or neurophysiology studies or neurocognition. I think this Tijana study is the only one that doesn't involve these technologies. But anyway, I would like to ask you, where do you think this field of design cognition using methods from neurosciences is heading to? We are at a critical moment, I think, by now. The field is recent. There's a lot of discussion. What are the main and the core issues that need to be solved before?
It seems like you can using neuroscientific methods, you cannot measure more elements at the same time. And when you're designing, I think there's a lot happening. So to me, it seems like it's a bit of finding ways to isolate specific elements or finding ways to measure more than one thing using these technologies and getting that from the data somehow.
Mm-hmm.
I have to kind of disagree with that, if I understood you correctly. So, for example, I've used EEG and I've used FNIRS, which is also a neurophysiological measure of brain activity, and you can use them simultaneously.
No, I didn't mean that. I meant
Okay.
When you are using them, I think it's questionable what you are actually measuring, what the results are telling you about the design itself.
Okay.
Because you are moving your hands, you're moving around while you're thinking about things, you're thinking about designs. So there's a lot that is going on while you're measuring. So you can use many technologies, but when you look at the data, you see something from it, but I think there's a bit of a question of what is it actually telling you about the design process?
Yes, the interpretation part is going to have it's a big part to solve, I think.
Yes, I would agree with this point. So I attended also on Monday the workshop that we have specifically on design error recognition, and but I can pretty much repeat also what were the conclusions then. I mean, I'm really new in the field, so I started with one preliminary study, but what I can also say about how do I feel at the moment is, okay, we can get some results. As I said, we have some differences. But if we really want to understand what did we measure, why do we have these differences, and what can we conclude with them, it is really hard, especially since we are not experts in using the devices or in reading these data. So we definitely need to connect them somehow with design. But to really make some kind of bold statements, I think it's at the moment really hard, and on the other hand, really crucial. I have this feeling for EEG, but also for eye tracking.
What I could add, so Sonia says this is recent. Yeah, it's true. It's recent, but it is no longer novel as a field. But at the same time, it is not mature yet. Mm-hmm. And it seems that more and more research groups are adopting these instruments. Maybe it is a matter of decreasing price. Maybe it is a matter of increasing interest and so on. So I hope you will not take it as an advert. I have written a review about the use of these tools in experimental design studies. It is already old, but my understanding is that what we will learn from these instruments, it will happen by discovery. So we will discover new associations we haven't thought of. For example, Fanica concluded her comments answering to Tijana, saying we have opened more issues than the gap we wanted to close, or something alike. In any case, we can take so many directions out of this first observation, and I'm not scared about this. I'm totally comfortable with that. At a certain point, even if we don't establish a precise research question, we will also see what comes out. Of course, we have a first objective in mind, to correlate some data, but it might easily happen that we observe a correlation that we haven't thought before. So I think we are still in this phase actually, and the multiplication of the studies and the fact that nobody uses these instruments the same way and so on suggests me that this is how it can evolve, at least in the short term.
Yeah. Okay, thank you very much for this lively discussion we had. Maria, I think we are on time, aren't we?
perfectly on time.
Perfectly on time. Okay, so thank you very much for your presence. Thank you to the audience as well for your questions. And well, let's enjoy the rest of the conference then. Thank you very much.
Thank you. Bye.
Thank you,
Bye.
everyone. Bye.
Thank you.
Bye.